So we have 1 o'clock, so let's start. So this is basically the story of me making a GHC proposal and then implementing it. So let's start with a word of warning. I basically wrote the talk proposal half a year ago, and I wasn't exactly sure how the whole thing would look like, so I wrote approximately what I'd expect it to be, but I had to change a little bit. AKA, I'm not going to talk anything about the type checker. It's mostly renamer because it's where the language extension actually ended up happening. I did change the talk description 2 days ago. So if you are one of the many people that just looks at talk descriptions like 5 minutes before you go into a talk, this does not concern you. Just a thing. So the beginning is basically you have an idea of what you want to change. So what exactly is that? It's basically something in Haskell which bothers you, and you think that you could be better. So in my case, it's related to duplicate record fields. So this is a more, I assume everybody knows duplicate record fields here. Hands up, who knows duplicate record fields? Okay. So very roughly, it basically gives you the ability to have the same label twice in different records. And then you can use set ID function here to actually access this record. Okay, how many of you think this code compiles? Well, yeah, right about that. You actually get a compilation error because it cannot figure out which label you meant, which record you meant. So this is basically my motivation is that this is kind of a useless selector, because to actually use it, you need to specify the type very, very closely. Why that is the case, I'll explain later. So it tends to be that you don't use that selector at all, because yeah, you can't really do anything with it that's useful, because it's very, very clunky to actually work with it. So what do people actually use it for? Or use it with? For example, you can do it directly with JSON, and then you don't have to do anything funny to actually derive your JSON decodings, or for database, or you access it later with lenses, so you don't use the fields anyway. So it tends to be that if you use duplicate record fields, you tend not to use the selectors anyway. So the idea here is, let's go from the beginning. Like, what does this actually generate? So this generates a type foo. It generates the constructor foo, which is a value, and the two functions bar and bas, which are then top-level functions, which means they basically block your namespace. Additionally, they also create the names bar and bas for record construction and record updates. And additionally, those names also for record wildcards in case you use them. So what do you do with this? You write a proposal for it, you put it up on GHC proposals, and you get feedback. So the idea here is to basically inhibit the generation of those selectors. That was the idea for a proposal. And then you get some feedback. In this case, it's basically name it something differently. And also have additionally a deriving clause for selectors. So the idea is that if you still want those selectors, you could add a deriving clause to get them back, but this is just an idea that will currently not get implemented. So, questions so far? So now that there's an idea of how this could look like, let's start reading up on what actually to do in GHC to implement this. So reading up is usually a recode. So you clone it, you build it, and because Haskell is self-hosting, which means the Haskell compiler is written in Haskell, you actually have multi-stage compilers. You have stage 0, which is usually generated from, it's some C minus, which you can compile directly. That's the stage 0 compiler. Then you generate from that, using the stage 0, you generate the stage 1 compiler, which is built from the current source tree. And then you take that stage 1 compiler and use it again to build the source tree again. And then that's the stage 2 compiler, which you will then use to actually run the tests over it. Or actually, that's the compiler you ship. And when you rebuild it, you can actually tell it only to build the latest stage again. That's the freeze 1. So in case you actually do changes to the compiler that will break it, because you cannot really compile itself, you cannot use a compiler that you broke to compile itself again, you can ask it to freeze, to freeze stage 1. So you can actually mess around with it and see how, if things compile and things do not compile, and use the current compiler, but still actually modify things. So for a bit more working with the compiler, this is a very valuable tool. It's hasktags, etags. It's basically a very crude way of actually doing code navigation, which just runs a huge or somewhat huge regex over your code and finds the symbols for it. And then you can, in Emacs, you can use find tag. I'm fairly certain there's similar things for VI. Because I found actually none of the IDE tools for Haskell can actually deal with GHC, just because it's a rather huge code base. And it has a few intricacies because of the self-hosting part that I haven't even haven't looked too much into it, because I assumed it would break things anyway. So using tags, it works quite well actually. It doesn't have the, like with usual IDE tools in Haskell, they tend to be on the slow side. So if you use tags, the stuff is basically instantaneous, even though Emacs complains that the tags file is so huge if you want to open it literally or not. So a few things which I learned the hard way. So the Hadrian, the build tool which I mentioned, puts it in _build folder. However, if you have stage 0 as the folder name, that's actually the stage 1 compiler in there, because it's the thing that stage 0 compiler builds. It's a bit confusing, but they don't want to change it anymore because people are now used to it. So, another thing which is more annoying, I had some weird error which the GHC just panicked out when I compiled it. I asked in the channel, and the answer was basically, yes, if you change any binary instance and you only do freeze 1 recompilation, it will actually just panic out because the interface files changed. And in that case, basically means as soon as you try to change something in binary, you cannot rely on the current compiler anymore, which means that you now have to have a working compiler. Or you can basically run no more tests over it, but your compiler actually has to compile fully and has to be able to compile itself fully before you can run the tests again. Because the tests build on stage 2 compiler and then on the stage 1 compiler, which is a bit annoying. And just as a word of warning, if you change the build flavor, that means you rebuild everything. And rebuilding the compiler on my machine here, which is an X260, so it has a somewhat acceptable CPU, takes a few 10 minutes. I think it takes like 20 minutes or so with quick or more. So if you lose your cache, you can go drink a coffee or 2 or 3. If you want to start actually working with it, getting help, it involves a whole lot of reading. On one hand, I don't know, so far, when I have dealt with code with a large code base, they tend to have like about 0 documentation at work. I have to say that GHC actually has pretty good documentation for a software project its size. There's those note thingies, which tend to be sometimes referenced, which says see note that. And they tend to be rather well written and actually help you understand how things work. So it involves a lot of reading, and you can trust that the thing you're looking for probably is documented somewhere. You just have to browse around it a little bit and find it. There's some wiki which has some basic information, but there isn't a whole lot there. Just the getting started things. And GHC on Freenode. Just ask people. They tend to be rather responsive and cool, so yeah. Don't worry too much about it. So this is more like the getting started. Now we'll be a little bit more on how exactly does GHC look like. There's this huge little graph, which goes from, you start out with the actual parser, which produces an AST, stands for abstract syntax tree, which is, well, your syntax tree. Then goes into the renamer, which takes your syntax tree and tries to figure out where exactly or what exactly are those symbols, like head or a bind symbol, what are they referencing exactly? Then you run the typechecker, which contain all of the magics. Then there's a phase called desugaring, which takes the thing generated by the typechecker and converts it into the internal format, typelisp. And then there's a simplifier, which simplifies set things, which optimizes your code, makes it run faster, takes a bit of time, but makes it. And then you generate code from that, which can either be JavaScript or LLVM or C++, and you run that through. One of the things is about how GHC is actually written. The compiler itself has, for a functional programming language, a rather imperative design. So you modify a whole lot of things on the AST while you're moving along. However, I will mostly talk about the first few phases. Actually, only on the renamer mostly. So the HSyn, which you see here, is the AST. And in each phase, you have a different main identifier. In the first phase, it's the RdrName, which stands for reader name, which is what you read in. Then you pass that to the renamer. The renamer converts it into a name, which is a referencing name, which actually points to a piece of source code, which specifies what exactly is this. And then you run it into the type checker. So what exactly is an RdrName, or what can it be? So there's four different things. The first one is an unqualified name, which is basically just an X somewhere, or you have an argument. It's basically anything without qualification. You can have a qualified name, which is if you use a module name dot. There's a small mistake in there, I'm sorry. Where you use a dot, and then you reference things that means this is a qualified name. So answer is a qualified name here. Then the other two are a bit more on how exactly GHC works. It's the ORIG name, original name, which tends to be used, for example, in deriving clauses, or also in GHCI. For example, if you reference something in GHCI, you can reference it without importing it. That's what an original name is. It does not care about import statements. So unqualified and qualified names are using import statements, while original names don't. So I've heard there is a compiler flag somewhere which allows you to use original names directly. But I don't remember about that, anything about that. It's more of a rumor. And the last thing is exact names, which already hold the resolved name. One example is, is the list. So if you have the list syntax and don't use overloaded lists, that is actually a name. So the compiler inserts an already resolved name in there. Or if you use template Haskell, because template Haskell generates already resolved names. If you use, for example, new name, it generates an exact name, which already counts as resolved. So another thing which is being used is a so-called occurrence name, which you saw being used in the unqualified and qualified and actually also original name module, which is the occurrence name, which holds the namespace and where that actually is from, and the name itself, which is in this case a fast string, which is a bit of a faster string implementation for the compiler. So the different namespaces here. As an example, we have a record. So TV name stands for type variable name, which is basically anything that's on type level is in that namespace. Person C here, the constructor, actually generates two things. One is in the data name, the constructor itself, and there's a worker, which is, it's a bit more complicated. Basically, the worker is what you actually use in your source code, which then references the constructor to construct things. This is specifically implemented this way because for new types, for example, the constructor doesn't do anything. So you still need a thingy which wraps your piece of information. So the type checker is happy, but the actual constructor, which you call at runtime, is basically identity, which gets then simplified out. And the top level selectors which you create are var names. So you have occurrence names. You need to look them up. So there's an OccName or a global reader env, which is per module. So if you have an import statement, each import statement has its own global reader env, which is getting used to resolve OccNames. The lookup is like any other map lookup, except it's a bit more specialized. They have their own very fast map implementation because this is an operation you do 100 of times whenever you compile something. Because for each thingy you need to look it up. So it's a hot path to actually go for it. As you can also see, this is actually a list, because usually what you'd expect from a compiler is that each thing which you look up actually only has one result. As you can see here, the return type also says you can only get 0 or 1 results. This has multiple ones because in the past has been used for error reporting. So if you have more than one result, this lookup function actually tells you, well, there's another function, not the lookup function, which gives you an error back and finds multiple. So if you get more than one back, that basically means that the compiler has to report an error, that there are multiple declarations of the same thing in the namespace. This is why you have multiple possible global reader element. So what's a global reader element? It contains a few things. It contains the name, which is the actual referenced symbol, the resolved symbol, the parent, which is basically useful if you use ... imports. Is it local or not, and where exactly is it getting imported from? So it can be that you have the same symbol in scope multiple times because of import aliases and fun things like that. So parent as an example, for example, if you have prelude ... that means you get a, that's basically then a parent it says a parent is prelude because it's coming from the ... stuff. So we talked about resolved names. What's a resolved name? Or how does it look like? You have the OccName, which is what it's getting resolved by. And you have a name sort. The unique is there for fast lookup, so it's basically a key which you use for maps, and source span is, as you might imagine, where the name is actually defined. So definition side. So for the different name sorts we have here, there is external names, which is anything that's imported. Wired in, similar to external, but for things that are compiler magic. Internal means it's for here, it's currently in module, it's defined in the current module, so it's not actually being imported or anything. And system is something coming also, something compiler magic-y as well. So short summary, we have RdrName, which is an OccName with maybe a module specification, aka qualification. We have an OccName, which is some string and a namespace where you should look it up, for example, variable namespace or type namespace. And there's name, which is a resolved occurrence name. So this is more or less how the renamer works. Any questions so far? Okay, so let's go back to duplicate record fields. So how does this work? Well, not this way naturally, because you don't have the option to actually return more than one name. So duplicate record fields means that you have multiple things with the same occurrence name in scope. So there's a different one, which is lookup for overloaded things. The type signature here is you can actually pass in a Boolean to see if overloaded is active or not. It's doing it in there instead of outside. You pass in a RdrName which you want to look up. And that's the RnM is the renamer monad, which contains the like the global reader.env and a tiny bit more. And you still have the maybe, which means you can find something or not. And then you have an either, where you can either return one name or multiple names. In case of one name, it's not overloaded, so everything's fine. And in case of multiple names, you have a list of names coming back. So yeah, we have this one here, which does not work. So the basic question is, why does it not actually work? Basically because the renamer or the type checker wants a name. It wants one name. So the resolution happens somewhere between after a renamer and before the type checker approximately. Which means you don't actually have the type checker going through and unifying your types before it tries to figure out which name it is. On the other hand, you also have a little bit of a chicken egg problem between trying to unify things and you don't exactly know what's being referenced. I mean, it's not an impossible problem to solve, but for now, actually modifying the type checker to figuring out things or what names should go in there based on the types is a bit harder. So the easier solution is simply do a few heuristics on what approximately should go in there. That's why duplicate record field selector usually are quite unwieldy. So how exactly is this implemented? Field labels have their own little data structure, which holds the field label string, which is exactly what it's expected to, which is the field label name. Then you have a Boolean, which marks if it's being overloaded or not. And the main point here is if you insert this into the lookup table, it actually gets inserted not by the selector, but by the field label name. In this case, FL label. So as a short example, this is actually like this in the GHC sources, so it's pretty well explained. If you have data, if you don't have duplicate record fields enabled, it's simply you have foo and the record selector is simply the function itself. However, if you have duplicate record fields enabled, it will mangle the selector. So you basically have an additional thing in the namespace which is mangled and not user accessible, but the compiler knows how to actually access that by simply whenever you try to look something up, it looks up a FL label and then later inserts the actual selector when it finds it. So it's a bit of workaround that works quite well so far. Any questions? So we basically set the stage. So how would it look like to actually remove the top-level field selector or just field selector? So let's go to the actual implementation itself. So let's start with a tiny bit of refactoring. Currently, the main point of how duplicate record selectors is implemented is by mangling the field name, which makes the whole thing a bit more complicated than it can be. Additionally, it also wires in the part where you generate the field selector in. You could theoretically remove that code, but then you have mangling on top. So there's the idea that you basically implement two new namespaces. One is for record updated, because record updates should still work. And the other part is that you now have a new record selector namespace. So by default, record selectors have their own namespace. And you can then additionally write code which takes that code from the record selector namespace and puts it in the regular variable namespace. So you can actually fetch it. Which basically means this should work. That you have a field foo and you can define an additional top-level variable foo and everything works. I did that. Got a funny little error which came from the assembler. This is basically because the assembler, you have to somehow generate your identifiers which you push down into the code generator. So, oops. I went down into, yeah.
Where was the assembler in that diagram? Like, past the simplifier?
Yes. I think it's past the simplifier. Or it might even be in the simplifier itself. I cannot tell you exactly where I got this error. I realized it's somewhere in the label generator. So I dug down and figured out how exactly are those things being generated. I just looked for a string closure. String search is still a pretty valuable feature on actually figuring out where things come from. And I adjusted the string generation to also include the constructor from the record selector namespace, and then everything worked just fine. I wanted to put the change on the slides, which actually fixed that, but I couldn't find it anymore. So it works now, but I'm not entirely sure because it uses pretty printing. So by adjusting a pretty printing thingy, you actually can fix that. Which is, I'm not entirely sure if this is like nice code, but so basically you're using the pretty printer for code generation. I'm not entirely convinced this is the right way to go about it. I'm not one to complain. So next change is you change the field label thing. Oh yeah, I forgot to mention what the A here is. It's basically a reader name or a name depending on which phase you are in. Because the syntax tree contains either reader name if you're before the renamer or name after the renamer. So because you don't need the field label string anymore, you can now remove that and simply have a field selector, but you additionally need to actually declare if something is a top-level field selector, which basically means that your renamer phase additionally has to generate those selectors or not. Next thing is we can remove the parent stuff because there's some code specifically for field parents, etc., which we don't need anymore. This is mostly relevant for duplicate field selectors. Then we, by the way, this is approximately how far I've come. So this is basically future plans. You have to reorganize the lookup. Basically, if you do record updates, you have to look things up in the record update selector namespace. Because now it's not in varname anymore all the time. And additionally, as mentioned, you have to generate those top-level field selectors which are in the varname namespace if you want them. Also, you need some sort of direct access, for example, for generics. Because generics can now not reference the varnames anymore if you actually want to use them, but they have to reference the records, things in the record selector namespace. Additionally, if you enable no top-level field selectors, it will break quite a lot of template Haskell code generation because it's not valid anymore now. Because you're now referencing things in the RdrName namespace which are not guaranteed to be there anymore. I'm not entirely sure how to do this properly. So, or how, I know how to do it is somewhat straightforward, but how to actually deal with the point where you could break things, or how do you do it backwards in a backwards compatible way, gets a little bit more interesting. So yeah, this is basically the whole plan. This is my sellout slide. I'm working at Zalando. We do e-commerce, selling clothing. We have about 2K engineers, and we have all kinds of things to work on. So jobs page, and merchant ops is the department I'm working on. And I would also like to thank Matthew Pickering, specifically for helping me out quite a bit at the GHC channel. So yeah, go ask if you need help, and if you want to build something, those people will help you. And also to Shane Fletcher, because he basically poked me. And he saw the proposal like 9 months ago and was like, hey, this looks interesting, we'd like to use this. Need a bit of help, and that's how basically I got the whole thing started. Yep, that's my talk. And questions?
Can you point us to code that you
Code changes, yes. I'd have to actually bring it up. But the biggest part is basically like those things I mentioned here. Basically the field label change and the namespace change are the two things I did so far, which is pretty much what I put on the slides. And then just to run through the GHC and adjust whatever compilers I can find. Yeah, I have a diff. I can pull it up. It's just like there is not a whole lot to see on, I think at least. Let me go find it real quick. I mean, let's see what we have here. I mean, it's not ready yet. Yeah, that's basically the main thing is I'm basically here. This is the next step to do. I originally wanted to do a bit of talk-driven development by saying, yeah, well, I have this extension here. But it turned out it's a bit more complicated than I originally assumed.
What driven development?
Talk-driven development. Yeah, I've never heard that term before.
I guess I think I know. Were you saying that the RdrName field selectors are also not available via this extension to generics? Is that what you were saying?
No, the main points what I was saying is that when you derive generics, that you now have to not do things like the functions in generics themselves should now be referencing field selectors and not var names anymore. And additionally, all the things you do with generics have to actually work with field selectors or with record selectors, because they are now in a different namespace. So you can, for example, do, I don't know how exactly generic works for updates, for example, but that now has to work with things in a different namespace.
Right, so it's more like operating it on as though it were truthful, let's say.
So one thing I can say about GHC, yes, it's a huge piece of software, but it doesn't mean you can just go dig in and mess around a little bit. It does involve a bit more reading than your average piece of code, but it also has, I have to say, better documentation than your average piece of Haskell code.
So I'm just curious, at the end of this process, when you have this extension turned on, what would the original problem space that you showed with duplicate record fields, what would that look like instead? What's up with that basic simple code block changed to? You kind of use the same identifier twice, but now you don't have any identifiers. How does that work?
You still have to enable duplicate record fields if you want to have the same identifier twice.
Yes.
So that's, I'm currently considering if that should be enabled by default anyway. But the main part is that usually if you use some sort of duplicate record fields is that you use an underscore beforehand. So you can still use that name. That's basically the main thing is, for example, if you generate lenses from it, you need to have something different than what the lens is being generated. And then you have prefix dropping in ISON generation, and the idea is that you don't have to do that anymore. It's more of a quality of life change in the end, that it doesn't block things anymore for you. It's more of a minor thing, if I would say, but it makes life a bit easier.
Does this have any effect on the Haskell type class?
The basic idea is, I didn't mention it explicitly, but it's in the proposal, it does not affect it.
Okay.
Because it wouldn't make sense, right? It's just the top level selector which you actually want to delete.
Right.
It does not affect anything else explicitly. Do we have more questions? Short talk then. Okay, thank you.